Let's go to page 242, number 372. Okay, it says three sides of the quadrant have length of 1, 2, and 5, and the fourth side is an integer x. What is the sum of all the possible value of x? Okay, so let's say if 5 is the longest side, so you have this kind of situation. You got 1, 2, 5, and x. Okay. So the sum of these have to be greater than 5. Okay, that means x can equal to 3, 4, or 5, right? Again, 5 is the longest, so x can also be the longest, even with that. So there's a possibility if the 5 is the longest. Now, if x is longest, then you have this kind of situation. You got 1, 2, 5, and x. Okay, so again, the sum of these have to be greater than x. So x can equal to 5, 6, and 7. Okay, it cannot be equal to 8 because then you won't have a quadrilateral. So the possibility would be 3, 4, 5, 6, 7. Okay, so the sum will equal to 3 plus 4 plus 5 plus 6 plus 7. So sum will equal to 25. Okay, let's go to next one. Okay, so next one, the picture is given. So that's kind of really nice. Okay, so you have a circle. And you have the tangent. And these are the tangent points. We got A, B, C, D, and this is T, and this is U, and this is R. Okay, so these are tangent points. So first, let's go and draw all the radius to the tangent point. Okay, and let's see what else is given. So again, angle D is 90 degrees. AR equal to 3. So right away, common tangents are congruent. So if AR is 3, AU will be equal to 3. And angle D equal to 90 degrees. And RST equal to 210. So okay, we're missing the S over here. So RST is 210. That means this angle is also 210 degrees. Okay. Okay, so radius and tangent are perpendicular, so this is perpendicular. So if this is 90, 90, 90, this would be also 90. And if this is 90, this is 210, that's 300, so this would be 60. Okay? And then if you cut this in half, okay, you get 30 and 30 degrees. And this would be the right angle, this would be right angle, so this would be 60 degrees, 60 degrees. Okay, so right away we know those facts. Okay, so let's see what are we looking for. We're looking to find the area of the circle. So we're looking for area of the circle. Okay, well, this is very easy. Just to find the area of the circle, you need to find the radius, right? So if this is 3, this would be 3 squared root of 3. So R equal to 3 squared root of 3. Okay, so now to find the area equal to pi R squared. So write out twice. So pi R squared, and so K will equal to 27 pi. Okay, let's go to the next one.
Okay, 374. It says two circles of equal radii are drawn such that each circle passes through the center of each one, of the other one. Okay, so this is the picture you'll have. If the distance between the center of the two circles is 6, so that means radius of the circle is 6. Okay, find the area of the region which is common to both circles. So you're looking for this area. Okay, so from here you can go and draw these things down. Okay, and you also can draw. You can draw this part over here. By the way, this is going to be your 30-60 spatial triangle. Okay, so if the distance is 6, this would be a 3, and this would be 3 squared root of 3, and this would be a 6. Okay, so 3 squared root of 3, 6. Okay, so that's what we have. So to find out the area of the region, so area equal to 2 times, so this is 2 segments, so it would be 2 of that, right? And then this will equal to 2 times. To figure out a segment, you have to use the sector minus the triangle. Okay, so again so the segment is equal to the sector minus the triangle. Okay, so the sector would be pi. So looking at this one over here, so pi r square, and since this is 60 degrees, so it'd be 120, so the sector would be 120 degrees out of 360 degrees. Okay, so again, pi r square is for the whole circle, and you only have 120 out of the 360. Minus the triangle would be 1/2. The base is this over here, which would give you 6 squared root of 3 times the height, which is the 3. Okay, so k equal to 2 times, and you can cancel this out, 1, 3, cancel out. So you get 12 pi minus 9 squared root of 3, and you multiply out, so k equal to 24 pi minus 18 squared root of 3. Let's go to the next one. Okay, so next one, the picture is giving. So you have a big circle. And you have the 2 perpendicular diameters. So you have divided into 4 quadrants, and then you have a circle that's inscribed in there. Okay, so it says diameter is 12, so that means this is 6. And looking for the radius of the small circle. Okay, so over here you again draw your radius to the tangent point. Okay, so this is a radius, so turn over here, so that's your radius, and this is a small r, and since this is a square, this is going to be a square root of 2 times r. So you have the square root of 2r plus r equal to 6. Okay, so you can square root of 2 R. That's from here to here. That's because this is R and it's a 45 degree spatial triangle. So from here to here, so this is your square root of 2R, and from here to here is the radius, so plus R, and that will equal to the radius of the big radius of 6. Okay, so let's go and simplify. So factor the R. Okay, and you divide, so R equal to 6 over square root of 2 plus 1, and multiply by the conjugate to simplify. So over here you get 2 minus 1, and multiply the top, and the bottom equal to 1, so R will just equal to 6 square root of 2 minus 6. Okay, let's go to the next one. Okay, it says a man is 6 miles east and 5 miles south of his home. Okay, so you have a home right over here. Okay, so you're gonna go 6 and 5. Okay, so here's the man. And he's also 3 miles north of a river. So the river is going to be right over here. And again, river run all the way across. Okay, and you're looking for what is the least number of miles he may travel if he must fetch the water from the river and then return home. So you need to go to the river, okay, and return home. So this is 6, this is 5, and this is 3. Okay. Now, to do this kind of problem, you have to use a reflection. So you have to go to the river and return home. So what you need to do is you need to reflect this over to find the point. You can reflect this over or reflect this over. So imagine that he's over here and he's going to go. So imagine he's over here, he's going to go fetch the water and go home. Okay, so it's going to be the same thing. So again, that's how you find the optimum. Okay, so you go to the river and go home. And the way to do it is to find this point, you just reflect this over, okay, and from here, from this virtual point, you go straight over there. Okay. So again, these are the same. Okay, so to find the distance, you just have to use Pythagorean theorem. So this is 3, 3, 5. So this would be 11. So you use Pythagorean theorem. So the distance will equal to square root of 6 square plus 11 square. So the distance will equal to square root of 36 plus 121. So equal to square root of 157. Okay, let's go to the next one. Okay, 377. Okay, so read through the problem and draw the picture. So in triangle ABC, CD is the altitude to AB, A is the altitude to BC. If the length of AB, CD, and A are known, determine the dB in terms of length in each of the following cases. Okay. Okay, so you have A, B, and C. Here's the E. And here's a D. Okay.
So whenever you're dealing with altitude, you deal with the area. So case 1, basically you're looking for dB. Okay, so looking for dB. Okay, so you're looking for this right over here. Okay, so first let's go and use the area formula. So the K equal to 1/2 base. So I'm looking at this triangle this way. So 1/2 BC, base times height, AE. Okay. Now if you turn it around, the K, if you look at using this as a base, it would be 1/2. The base would be AB, and the height would be CD. Okay, so if you look at using this as a base, okay. Now, since both are the same triangle, just look at different direction. So they should have equal area. So you say this is equal to each other.
Seventh and eighth grade students, if you have your Royal Snack coupon, you can redeem that at the snack bar. 7th and 8th graders, come and get your Royal Snack with your coupon. Thanks.
Okay, so multiply both sides by 2, so this cancel out. And I'm going to divide this over. So BC will equal to AB times CD over AE. Okay, so then next what we need to do is we need to go ahead and use the Pythagorean theorem over here, because now we know what BC is, but now and all this stuff, but we need to get the dB. Okay, so dB squared plus DC or CD square. So this side square plus this side square will equal to BC square. Okay, and we kind of do the BC ahead of time because we need to get the Pythagorean theorem for that. Okay, so you got dB square is equal to, you move this over, okay, so be BC square minus CD square. And then substitute this into here. So dB square equal to AB times CD over AE square minus CD square. And then what we're going to do is we're going to make into common denominator. Okay, so making the common denominator, and then we can go and factor out the CD square. So factor out the CD square, and then you end up with AB square minus AE square over AE square. Okay, then you take the square root on both sides. So dB will equal to, so you take the square root, this can come out, so it'll be CD times the square root of that would be, and I'm going to separate, I'm going to separate the two terms. Go back to, instead of doing all this, probably just going better to just go ahead and factor out. Yeah, that's not combined. Just from here, just go and factor out the CD and take the square root. Okay, so you're going to get AB over AE square minus 1. Okay, so you can take the square root, so this comes out, and from here, okay, you just go ahead and just basically I'm using this one here. Okay, so factor out the CD, and you end up with these. Okay, so just factor out the CD and take the square root. Okay, so not doing all these. Okay, so you end up with that. Okay, so we found the dB equal to that. Okay, now, so for 1, okay, this is good for, so this is good for both for acute or obtuse. Okay, so this is good for case 1 and case 2. Now case 1 and case 2. Okay, so this is good for case 1 and case 2. Now for case 3, okay, if angle A equal to 90 degrees, so think about angle A is equal to 90 degrees, and the D would becomes A. Okay, so D becomes A, and therefore DB becomes AB. Okay, so again this becomes that. So DB. So you see this point keep going, keep going, keep going. So the DB becomes AB. Okay, that's for number 3. Now for number 4, okay, if angle B is 90 degrees, then D becomes B. Okay, and then DB equal to 0. Okay, let's go to the next one. Okay, number 378. Okay, the picture is giving. Okay, so you have A, X, D, B, and then you have this situation over here. And this is point E. Okay, so CE is equal to 12, AE is equal to 8, AB equal to 14. So if AB equal to 14, this would be a 6 over here. And AD equal to 10, AD equal to 10 right over here. Okay, looking for AX. Okay, so you're looking for this right over here. Okay, well first let's go and find the DE. Okay, this one D, we can find that fairly quick. Okay, so DE times 12, right? So here's your here's the vertex, the point intersection. So DE, so ED or DE, so this times this equal to this times that. Okay, so divide by 12, divide by 12. So DE equal to 4. Okay, so this becomes a 4. Okay. Then what we need to do next is we need to go and use similar triangle. Okay. So if you look at this right over here, notice the angle A subtend BD, same as angle C, right? So angle A and angle C subtend the same arc. So angle A and angle C are congruent. Okay. So your angle A is congruent to angle C. And also the angle X is congruent to itself. Right? That's a reflexive. So now you have an AA theorem. Okay, so they are similar triangles. So I'm going to draw the triangle in a different way. Okay, so basically what you have is this kind of situation. You got A, X, B. Okay, and then you have this kind of situation. And you have actually, you know, let's back up a little bit. Let's go and do this part first, okay? Let's go and do the vertical angle. Since these two are vertical angles, they are congruent to each other. Okay. So you still got AA theorem, okay? So you can angle A congruent to angle C, and this angle congruent to this angle because the vertical angles are congruent. So by AA theorem, they are similar. Okay, those are similar. And so this is 10, this is 4, this is 8, and this is 6, this is 12. So you can see that this triangle is 1.5 times that, right? Okay, so again, 4 times 1.5, you get that. 4 times 1.5, you get that. So 10 times 1.5 will give you 15, okay, by using a similar triangle. Okay, so this would be a 15. Okay. So now we're going to look at, so now we're going to look at, and actually this is the D, and this is the B. Okay, so we look at the ADB and E, this is the E. Sorry about that. Okay, so basically we use these two triangles. So you got ADE and CEB. Okay. So this from here, these two are similar and they are ratio of 2 to 3. So from there we can find the 15 from here. The next step, what we can do, we're going to look at the big triangle now. Okay. And I'm going to separate the two triangles. Okay, so this is AXB. And this would be CDX. Okay. Again, they are similar triangles. Okay. So AB equal to 14 and CD equal to 16. Right? 4 and 12 is 16. 6 and 8 equal 14. So the ratio is 14. So the XB, so XB over XD, so this over that is equal to 14 over 16. Okay, that's your scale factor. And that's going, I'm going to call this X, I'm going to call this Y. Okay. And okay. So by looking at, so XD is X, so XD is X, and XB is Y. Okay. And so the scale factor, so this is going to also, so 14 to 16 is also equal to Y over X. Right? So again, Y over X is equal to 14 over 16. So once we have this relationship, we can solve for y. So y equal to 14x over 16. So y equal to 7x over 8. So kind of keep that off to the side. So now we can go and use the point theorem. So now we can see, so from point to circle, so xd times xa will equal to xb times xc. Okay, so from here to here, so point to circle times point to circle equal to point to circle times point to circle. Okay, so xd is x, xa is x plus 10, xb is y, but y is 7x over 8. Okay, again, this is y, but y is this over here, so that's y. Okay. And xc is y plus 15, so it'll be 7x over 8 plus 15. Okay. So again, this is y, and this is y plus 15. Okay. Okay, so now it's just a matter of working it out. So you got x squared plus 10x equal to 49x squared over 64 plus 105 x over 8. Okay, so basically I make this into common denominator and I add. Okay. And well, I distribute, multiply, distribute. That's what I get. Okay. Okay, next, let's go and multiply by 64 to get rid of the fraction. So I get 64x squared plus 640x
equal to 49x squared plus 840x. And move everything to one side to make it equal to 0. No, actually, let's go and move this over because we know x cannot equal to 0, so we can go and we can do that. So minus 640x. There we go. So we don't even have to do factoring. So we got 15x squared is equal to 200x, and divide by 15x, divide by 15x. So we got x equal to 40 over 3. Okay. So once we find x equal to 40 over 3, then ax, so ax is equal to x plus 10. So ax equal to 40 over 3 plus 10. So ax will equal to 70 over 3. So this one is kind of a little bit lengthy. You have to use a lot of stuff. Okay? So you kind of have to work through carefully